So welcome, and let's give a warm welcome to your friend and mine, Mr. David Duffett.
Good morning. Are you having a great AstriCon? We're all having a great AstriCon, haven't we? We've had so many people feedback what a great AstriCon it is, full of great talks, probably the best talks ever this year. Great traction through the exhibit hall. And could I have my presentation up, please? And I have a few domestic reminders to give you. So the first one is be sure to give your feedback through the Shed or the Sketch application, astricon2017.sketch.com, and your feedback is very valuable. I forgot to mention yesterday something very important, that this year we have a Geek of the Week award. So at the wrap-up session, where the Asterisk dev team will be talking about what's going on in Asterisk and what's coming down the road in Asterisk, we will make an award to like the cricketing man of the match for AstriCon. And it's an exciting award. It's a Raspberry Pi, and to celebrate the excitement of video in Asterisk, it has an HDMI screen that's only 3.5 inches big, and it has an 8 megapixel camera, and it all comes in one lovely bundled package to give to the lucky recipient. So your feedback is very, very important. Everybody moved briskly between the sessions yesterday, so that was great. The developer extra track is still in the Oakmont room, apart from one of the talks, and that is the one this afternoon. It's the panel session. You've probably seen how historic this is. We have the free switch guy, we have the Asterisk guy, we have the Camaillio guy, the OpenSIPs guy, and the Homer guy. They're all going to be on this stage. That session will be in this very room, just ahead of the dangerous demos, because we anticipate great demand for that. Now, the Digium team in Huntsville, Julie, you've probably noticed Julie. In fact, where is Julie? Is Julie in the room somewhere? Julie at the back, and Tash as well. I must say a big thank you to Julie and Tash for doing the organisation. In fact, we should really give them a little round of applause, shouldn't we? Because things have gone pretty smoothly. It's very good. And Julie wanted to say a special hello to everybody back at the Digium HQ, the team there watching, because we're live streaming this. So, hello. So we did Geek of the Week. National Ballroom A, just in case it rains, for lunch. And once again, the dangerous demos. And these are going to be very dangerous indeed. They're going to be in this room. I don't know whether you've seen dangerous demos before, but just in case you've not, there are two podiums. There'll be one this side and one this side. And people get a very short amount of time. Where's James Bodie today? Where is that James Bodie? Is James Bodie still outside? By the way, James Bodie gifted me these orange pants. What do you think? Exactly. It's not every day I accept a gift of orange pants from another man, but it's just one of those things. Anyway, the dangerous demos are very dangerous, and I'm not allowed to be on the judging panel this year because I've been told I need to do a dangerous demo, and so myself and the Digium team have been working very hard on the mother of all dangerous demos for this afternoon. Okay, I wanted to say a couple of other things, and that is, yesterday I talked about the open source showcase. Today I'm talking about the open source projects represented here at AstriCon, and there's a subtle difference because there's a big free PBX logo just there. Those boys are down there in the expo hall, and as you've seen, they've got lots of very nice giveaways to give away. So do avail yourself of these things. And the last thing I wanted to say is Asterisk gets into all corners of the world, including Persian language speaking countries, and there is now an Asterisk book available in Persian from our good friend Mojtaba. So if you would like a Persian Asterisk book, this would be the place to go. So with that, I want to introduce the man that made it all possible, the reason why we're all here today, the creator of Asterisk, Mr. Mark Spencer. Do come up.
Welcome again, everybody, to Asterisk, or AstriCon, I should say. Maybe for a few people, this is a welcome to Asterisk, but it's been really exciting to come and see all the projects going on. It was particularly fun for me to see some of the one of the talks yesterday about the performance of ChanPJ-SIP versus ChanSIP, for example. Having written the original ChanSIP, it would have been a time to use a lot of swear words back then when SIP was much less standardized than what it is today. Anyway, it's been a long ride getting here, so Asterisk is I've been in development for about 18 years. And it's funny because I was actually just thinking the other day about how people said, well, you know, thank you for starting Asterisk. And I was thinking about how, as a kid, you know, you'd get chastised for, well, you started this, but you've never finished it. And I was thinking, well, we never want this to finish. We want this to continue to continue to develop as long as it can, as long as it continues to derive value. So I want to thank everybody that continues to participate in making Asterisk have this incredible life that it has had. One of the things that's been kind of fun along the way is there are a couple of people that I know that have done classes that involve Asterisk, that have used Asterisk in teaching some of their classes. One was actually at New York University, which was kind of an interesting arrangement because it was their interactive telecommunications program was not actually in the engineering department, it was in the art department. So it was kind of fun to see the kinds of projects that came out of that, like the plants that would call you when they were low on water, and the Canal Street murder mystery that played out on payphones that you would call into a number and then hear the scene that was taking place in that portion of the station. But I have a great friend, Brian Capouch, who has been teaching Asterisk at St. Joseph's College. And we've had a lot of his graduates that have gone on to do careers involving Asterisk, and that didn't necessarily come to school thinking that Asterisk was what they wanted to learn, but then when they graduated, they sure had some successful outcomes, including Kenny Schumard, who actually worked for Digium for quite a while and made some important contributions in Asterisk. So without further ado, I am going to introduce Brian Capouch.
So, hopefully here, they got the microphone on, and my presentation will show up on the screen here directly. And once that happens, I will get started. Oh, I bet it's because my screen has blanked. Nope. There we go. Okay, so the title of the presentation here is all about Asterisk and Me, a Telephony Love Story. And I know it sounds kind of sappy to call it a love story, but that's kind of what it amounts to. I ran into Asterisk many, many, many years ago. This is me, if you'd like to email me. And this is a link. I hope you can read it. This presentation is actually part of the slides.com thing, and it allows all kinds of wonderful things to happen. And so if you're out there and you have a phone or a laptop or something you'd like to follow along, you actually would be watching the slides progress exactly at the same. Here I have a remote control on my phone. It's a really cool thing. And so I'll leave that there for just a moment. I need to keep moving here. We're going to do some demos today. This is the plan for the day. At first, I want to spend just a few minutes telling you a few things that I've done with Asterisk. During the time that I've played with it, it has been a very important contribution to my life in my past. I also did a project especially for AstriCon 2017, and I wrote an API wrapper in GraphQL. Now, I am blinded by the lights here, and so doing little survey questions doesn't work very well, but I know some of you have talked to me that you've heard of GraphQL. Part of the presentation today is if you have a laptop with you and you want to play along, I have a GitHub repo that you can run. You can actually access the API through GraphQL here in a little bit. And so when we get to that part, if you're a developer and want to play, you're welcome to do that. And then finally, I want to tell you what I'm going to be doing once I leave AstriCon, where the past that I've lived and the future the present that I live meet in the future. So without any further ado, now I see that when my phone blanks, I lose my controller. There we go. So the first part of this is about yesterday. That is some things that I've done with Asterisk, just a brief review. The first thing is it has helped save the history of this little town of Madeiraville, Indiana. And there is the plat of Madeiraville. It's a little tiny town. It was built along a railroad in 1853. It's a railroad town, and it is essentially dying. In 2004, I bought a building, not knowing that at one time it was a hotel in Madeiraville. So there's a picture of the Gangwer Hotel, and here's a picture of the Gangwer Hotel today. So this is one of the buildings. I actually own 8 historic structures in this little town. And I wanted to show you a couple of other pictures, the building there on the right and the gentleman standing out on the street. This was Dr. Hackley's home and office, which I own. It was built in 1876. The hotel here was built in 1853. It's the oldest standing building in Pulaski County, Indiana. So that was Dr. Hackley's house, but what has turned out to be germane to this talk and a big part of my life, this is a copy of a postcard that came out in 1921, and on the back it's marked Telephone Exchange. And this was the house that housed the Maderaville Telephone Company beginning in 1908 and going through the 1940s. And this is another one of my properties, and it's going to show up a little bit later on in the talk. So some of the challenges that I faced there, I have these historic structures that are precisely historic structures because they are in a town that is dying. That is, nobody ever put new windows in them, nobody ever put new doors on them, the plaster's still on the walls and everything, and so that is an interesting angle. Security is a constant concern, and if you'd like to talk to me about the opioid crisis, I could tell you how it's affected my life once I bought these old buildings in a town that's dying. It has been a constant hassle to try to keep those houses in place, and I don't have any money. All right, so that's another thing that recommended a solution that didn't cost much. So what was the solution? Well, one time, about 2004, 5, 6, somewhere like that, I had about 100 of these things. Netgear WGT 634Us, and the key to this wonderfulness is that they had a slot where I could change the Wi-Fi card. They also had USB. And so what I did with them, basically, was that I set them up. Each one of my houses has a router inside running on Open WRT. There's an Asterisk server running on a separate box where the USB connects me up to a flash drive so that I can store my voicemail, my messages and things. And then equally important, I have, if anybody here knows what X10 is. X10 is a home control communications technology, and I rigged it up to talk to Asterisk such that if somebody opened the door of one of my houses, the motion detector on the floor in front of the door would send a message to the X10 control program. It would then send a file to Asterisk. It would drop a call file in, and Asterisk would call me and say, hey, there's somebody just walked into the old hotel. Maybe you want to check that out. And so it turned out to be a wonderful, wonderful way for me to manage these houses. Now, here's an example. This is another house I own. This was a banker's mansion. From architecturally, it's a 4-square with craftsman detailing, and I just wanted to show you that unobtrusively, if you home in on the upper corner of that, you'll see I have a little antenna there that's hanging off the top of it. And so all my houses look to all the other houses, and each one has a little Asterisk box running up in the attic, and I use those to control my houses. In about 2005 or 2006, I did something else, and this was back when minutes cost something. Of course, now they're free, but back then it was significant. Out in rural America, it was long distance to call the next town over, and in some cases, if you were right on the boundary between two towns, you could spend 50 cents a minute making a call to the next town. So what I did was, I had this thing called People's Wireless. I set it up with farmers. Farmers all, where I live, have big grain elevators sticking up into the air, 60 to 120 feet. And so we went to those things, we put laptops up in boxes, and I'll show you a picture of one. And we built a network that was 900 square miles. It had about 42 different farmers who were helping me, and it was a self-healing, somewhat redundant network that used Wi-Fi links between all these places. And so what I did was that at each site, the farmer who had the place agreed with me that they would put a phone line in. They would let me hook my Asterisk box up to their phone line, and I'll show you, I brought one, and now it's gotten away from me in the preps here, but it had an Asterisk server on it, a little PCI FXO card, the X100P, which many people here will remember, and then it had a dial plan such that if you made a call with a prefix to one of the neighboring towns, Asterisk would pick that up and say, okay, that's the one in John Doe's grain elevator, and it would pick up the local phone line there and make the call. So we actually had local dialing between about 22 different communities. And I gave a talk about this back in 2006 or 2007, and later had somebody from the regulatory side of things came up and said, do you have that legally done? And I said, well, I don't know what that means. You know, what do you mean legally done? In any event, the farmers enjoyed it a lot, but then minutes became free. And once minutes got to be free, then that whole thing was less important. So here's a picture of my neighbor's place. This is one of our hubs. I just went over there the other day, and this is kind of a typical farmer's thing. He has a business, and that's why his name is on the barn there. But if you home in on the top of that elevator, this little thing right here, this is the history of this. This was a 2.4 gig system sitting in a fisherman's dry box that we put up in 2007. Now this is a new 5 gig, much cheaper, much more efficient. We actually wound up though, since minutes got to be free and the internet became more common, we really don't have those out anymore. So anybody here who's never seen a X100P, that's what they look like. It was a PCI card, it would do one line, pick up the phone when you needed to, and it made wonderful music for me. This third thing that I wanted to talk about here is about teaching VoIP, and unfortunately the place where I taught VoIP for 34 years is no longer around. That is, I retired in the spring of 2016. St. Joseph's College closed in the spring of 2017. Don't ask me to talk about the details of that, but I wanted to tell you that I taught classes beginning in 2002 every other year. So 8 times I taught a college class in voice over IP. I wanted to share with you a little bit that it was a perennial problem to find a textbook, because after a while we're going to do something where you're all going to have to kind of prove to me that you understand how telephones work. And I know this is going to sound funny, but I would bet that many of you have probably never seen a telephone in the sense that I'm going to show it to you here in a little bit. So we use the Asterisk book, the O'Reilly Asterisk book, but at the same time, many aspects of telephony, many aspects of networking, which are important for voice over IP, are taken for granted when you use that book. And so I just wanted to mention that through my career, I always prayed someone would write a textbook for teaching VoIP, and now that's a project I may try to take on myself now. I started out, we had one server that all my students used, and at the end of it, we had morphed into the case where every student was running Asterisk 3 different places at the same time. The students each installed Asterisk on their personal computers. Whoops, screen blanking time, sorry. They also then had one on a private cloud that we had built, and then we also had a cloud server. So each one of them, and so for 22 students, we had a total of 75 servers that we worked with, and so we set up area codes and different kinds of dialing between area codes, and we were able to do all kinds of really interesting things with it. And I do wish I were able to still do that today, but the college is no longer around to do it with. And so I want to talk next. We're at part 2, and I will also tell you all, I have a timer down here that I'm supposed to watch, and I noticed for about the first 6 or 7 minutes that it said 30. It didn't change. Now all of a sudden it's jumped 10 minutes forward all at once, and so I'm panicking a little bit in that I now know where I'm at, and okay, so here we go. So if this was the project. So I took this on after I talked to people at Digium about a month and a half ago. I have spent most of my time recently doing web stuff. I'm a JavaScript programmer now. I've fallen in love with Node. For any of you out there who know both of those things, the question that I tried to solve in this little study is, what would a GraphQL view of the ARI API look like? Now here, I'm not talking as much to the marketing people as the coders who are out there, but in general right there, if you want to try, if you have this presentation on a device, you can click that link. If you have a laptop with you and you want to play along, I've opened up my machine for the duration of this talk so that you all can use it to talk as well if you'd like to. I'm going to go kind of quickly through this because this really is probably of limited interest only to those who are coding, but it is something that I just finished a few days ago, and it was right fun. Now, if you've never heard of GraphQL, the browser in my mind is the future, and I think many of you probably buy into that as well. And because of that, or maybe not because of that, what it presents to us is a universal virtual application container. So if I write to the browser, I automatically, basically, by using a modern language like JavaScript ES6, and I've had several conversations about people who program who hate JavaScript, okay, and I always ask them, have you coded in ES6? And their answer is always the same, what's that? Okay, and so if you haven't played with JavaScript lately, JavaScript has really come into its own right now. And so the idea behind the browser being the place we do these things is you write your code one time and you can run it anywhere. And if that sounds familiar, that was the That was the motto for Java when Java was at its prime here a few years ago. So what is GraphQL? Well, GraphQL is, I hate to say a replacement for, that isn't quite true. By the way, anything that's yellow in this is a link you can click. So if you go to the presentation either now or later and want to read up more, there's a discussion that I found that was very, very interesting about REST and its weaknesses. It's hard to discover what the API is all about. If you don't have external documentation for an API about, the only way you can do it is just play with it and see what happens. Oftentimes with APIs, with REST, you have to do multiple fetches to get all the data you want. You get one fetch, discover something, use something that you got in that fetch to do another fetch, and so on. And it's also common that you get back what REST gives you, whether you need it all or not. GraphQL uses a system whereby both the client and the server share a schema. And if you're a SQL people, you know what a schema is all about. So the schema is a typed schema. The client and the server both know the schema, and so the client basically makes a request to the server for the data that the client needs and nothing else, okay? And so basically what I want to do here, or what I did do for this whole thing, first I had to convert the API specifications, which right now in Asterisk are written in Swagger. Now, it's Swagger 1.1, and toward that end, I'm not going to say anything more, but many people out in the audience right now know what I mean when I say that Swagger is now open API, Swagger is now at 3.0, and that has caused some issues, and it caused a lot of interesting times for me as I did the conversion. I had to pick some APIs to convert. I didn't have the time to do the whole thing. This wasn't a project that I wanted to do. I couldn't afford to devote a year to. So what I did was I picked out a couple of the APIs and I wrote a wrapper that actually calls the internal Asterisk ARI interface and gets the data, wraps that data in GraphQL, and then presents it out. So I used a bunch of programs to try to do this automatically, and I made these colors according to the success level I had. API spec converter did not do, and these are all links, by the way, all the way to the bottom one. There's no link to my manual conversion. But API spec converters had trouble with certain kinds of cross-references in the files. Swagger to GraphQL could not handle external references, and if all your definitions weren't in the same file, it couldn't handle it. API-matic, I made yellow. It costs money, all right, but it did the best job, and in the repo there are a bunch of examples of translated files that I did if somebody wants to study up how well it worked. Eventually what I did was I just got the JSON files that do the spec right now for Swagger, and I manually converted them, and it worked beautifully. It wasn't nearly as hard as using an automated system to do it, okay? And so, which ARI APIs to do? I wanted to try to show both reads and writes. Mailboxes didn't work for reasons I was just talking to Jordan about a little bit ago. When I got it done, I realized I was going to have to do a lot more work than what I did. So what I chose was sounds and endpoints. And so if you're familiar with the ARI API, that's what we're going to look like. So now I'd like to switch over here. Now several things are going to happen here that kind of complicate life. Here is some of the code. So this is the definition. Basically, GraphQL objects are made up of mutations and queries. So a mutation is something that changes the state of the underlying system, and a query is something that simply comes in and asks a question about something. So this is an example. This is a GraphQL specification file that basically the only mutation that I did was send message, which is part of the endpoints API. Now, there is the endpoints GraphQL file that shows you basically this is what we keep, and this was translated directly out of the Asterisk documentation. I tried to use the exact same identifiers that they were using. And then finally, the key to this, for those of you who may be coders, for GraphQL, every single query has to be resolved. And so in this file right here, so this is the endpoint, get endpoint call, and this is the resolver for it. And you can see in each of these cases what I'm doing is making a connection up to a machine I have running, credentializing myself, and then basically running a client that makes the request using the ARI interface that's there right now, and then it gets automatically wrapped into GraphQL. And I'm not going to dwell on that code, but I do want to show you what it looks like in reality. So here is another cool thing about GraphQL. Every GraphQL system comes with an automatic viewer that is part of it that you can start up just by you basically implement an option that I want to run graphical, which is this interface, and now I have that, and this is two key things. Over here shows you the schema. So as I told you, in GraphQL, everything that just queries data is called a query. Anything that changes it is called a mutation. So the queries that I did are as follows. Those of you who know ARI, this will look familiar. The sounds call returns a bunch of sounds in an array. Get sound, I have to have the ID of a sound, and it returns a sound, and so on. And you can walk down this tree. So what's a sound? Well, here's a definition of a sound. This is also straight out of the JSON. A sound has a string ID, has some text going with it, and then it has a list of format language pairs that goes along with it. For time purposes, I'll show you what a query looks like. So you wrap the query in JSON, and here's the sounds query. So this window basically is where you put your query. This is where the results will show up, and assuming that I have a connection to my server, and this is a fairly long call, please come back, okay? This one does return a lot, but it doesn't look to, it should have returned something by now, and of course I'm demoing this live, and I'm not going to try to debug it now because I have an audience in front of me, okay? Let's try one more here. But this would indicate that I'm not talking to the back end, is what it would indicate. Now here's where the back end is sitting here. Uh-oh, we've got something going on over there. That's the Asterisk server that's serving me. So anyway, let me try one more thing here. Let me try mutation. You can see, though, that it knows the schema. So I start a mutation like this, telling it's mutation. We only have one, which is send message. And notice that it's helping me out here. Also notice that my keyboard is not too hot. SIP 8006. And I want, whoops. It'd be nice if I watched what I was doing. 2, SIP 8005, and the body of my message, for the sake of something simple, hi there. Now, since it doesn't look like it's working, we're not going to dwell on this, but if it does work, I need to, actually, let me get this query on here. Now, I hope this doesn't mean my machine is not talking to the world, because if it's not talking to the world, later on here, we're going to have other problems. Okay? But let's see if I reload here, if I do any good at this. Yep. So we got a problem somewhere here, so I'm going to move on, and you can add this to the list of things that I tried and the audience was understanding, and now we go on with the slides, okay? So, and of course, 2 minutes, once it's over with, you guys can come up here and I'll say, well, here's what I failed to do, you know, and of course, it was demonstrated earlier today 15 different times. So you did see the schemas, you did see the queries, you did see the mutations, you did see the resolver functions, you just didn't see it work in the GraphQL user interface, okay? So that's what it looked like for those of you who may not have been able to see it well here. And now, and we're finished with that part. I've got 10 minutes left to talk to you about chasing the dream. So once I leave AstriCon, I'm heading back to Madeiraville, and in that telephone company office that I showed you, over the past 10 years, I've acquired a whole boatload of magneto telephone equipment. I have, I think, 8 switchboards, about 120 phones. I've got power equipment. I have catalogs from the company. They all come from a single telephone company, the Kellogg Switchboard and Supply Company of Chicago, Illinois. They were one of the competitors to AT&T. I didn't bring pictures of everything, but I did bring one of my phones with me. And so what I'm going to try to do during this is to actually make a call on this thing, which is a mobile phone from 1910, okay? And I've created a little project called Magnet, and the star in the middle of that. So the idea is we take magneto telephones, we hook them up to the internet, and Asterisk is the tool that we use to do this with, okay? Now, first, I'd like to briefly show you how a telephone works. And of course, I can see people rolling their eyes. But here we get to see the telephone in its most naked sort of original form, which was the telephone of yore, all right? So a classic telephone set basically just has 2 circuits in it. A DC talk circuit that has 4 components, a receiver, a transmitter, a battery to provide power, an induction coil that takes the little tiny current that comes out of the speaker or the microphone and amplifies it and sends it down the line. It also has an AC circuit that is used for signaling that consists of a generator, which generates about a 70-volt AC current, and a ringer assembly that, when it receives such a current, makes a sound. So this is what, in the old days, this is about a 1903 diagram of what's in a telephone. And the components, starting at the bottom left, there's the receiver. The hook switch is what chooses between the two modes. The left-hand side of the diagram is the talk circuit, the battery, the transmitter, the induction coil, the receiver. On the right-hand side, you see the bells and the generator, and then, of course, there's a pair of lines that attach it to the outside world. So here is the phone that I've got right here, and on the front here, you can see on the top, there's the two terminals that attach it to the outside world. There's the receiver on the left, and there's the transmitter, and hiding behind this little thing right here, because this was a mobile phone to be used by linesmen, are the bells, but they're protected back there so that the linesman doesn't catch the bells on something and wind up knocking them off. So here's what the inside looks like. On the left-hand side here, here's the hook switch that goes between the two when you pull up the receiver. There's the generator. There's the induction coil. There's the battery, which, of course, in the old days were not so nice, and there's the back side of the ringer. Okay, briefly, what you're going to see today is that I'm not going to crank the crank to make the phone work, and that is because I'm not going to show you. This is an isolation transformer circuit. I mentioned to you that the signaling part of this is 70 volts AC. It also turns out to be that many old telephones, the metal parts, are connected up to one of the two lines up there such that if a ring comes in while you have your hand on this thing, and let's say you have your feet in the bath water, all right, just for fun, you've taken your portable phone with you to the bath, and you're making a call, and you have your finger there, and all of a sudden a call comes in, you're in trouble. So the phone here I've rigged up, and I'll show you here in a second. Right there is a picture that I took yesterday of the rig. And so down here, because I can't ring to get a signal as a switch, this is an old-fashioned 1900 light switch. There's my isolation switch. Here is the ATA that hooks me up to Asterisk. Here's where it comes up here and hooks up to the top of the telephone, and this is where it all goes together. And so in a little bit, I'm going to try to make a phone call with this, but first I want to tell you just a little bit more about this. So I own the Madeiraville Telephone Company, and the Madeiraville Telephone Company is a thing once again. All right, I have 8 switchboards in there. I've got about 100 telephone sets. I have ringing and power equipment. I've got literature. I've got ephemera. So what do we do with it? Well, what I want to do is I don't want to alter the phones because they're historically significant. So that was one of the desiderata. I can take a phone and unsolder things and put in modern components, but at that point what I have is not a historic phone anymore. I have an altered phone. Okay, I also have to deal with the fact that in the old days, the phones didn't have dials on them, all right? So how do you get in touch with the person you want to talk to? Well, you got to tell somebody, all right? So there's where we put the most work in. We've set it up such that I can route the flows through the old switchboard. So let's say you're calling the phone that's in the front room of the telephone company office. Asterisk brings it into the switchboard. A call drop falls on the switchboard. The operator picks it up and is then talking to Asterisk and says, "Number, please." And the person on the other end says, "Oh, I want to talk to Jenny," you know, in the front room. They can connect them. I also, since it's not possible to always have an operator on duty. You may or may not know this, but in the old days, I actually think this next slide is a picture of an operator. Yep, that is Elsie Hansel sitting in the very house that you saw a little while ago in 1917. She was 17 years old. Her son gave me this picture, and you can't see very well on the overhead here, but this is inside that house that I showed you a picture of earlier, and now we freeze frame forward 100 years. There's the spot today where Elsie was sitting in 1917. I have a little switchboard sitting there. I didn't have the presence of mind to take a picture of all the Asterisk stuff that sits behind it, but basically it's similar to what I have here. It hooks up with a pair of lines that are coming out of the switchboard to an Asterisk server, and at that point I can do with it anything I want to. And so now I want to finish by showing you how this thing works. And so, Kelly, if you want to, so he's going to show you a shot here. Now we're into deep technology here. This may or may not, we've been to hell and back with this the last couple of days. So there's what I got, all right? And as you want to pan over here a little bit, there's my 2 lines that come in the top. Over here, I think they hid the ATA, but over here on the side is my switch that controls all this stuff, all right? And then The lines come from the switch and come up here, and I will show you further, and I think I have this now. This is where I need 14 hands, okay? So if you're interested in reproducing this, if you go to the Asterisk Speech Recog repo out on GitHub, we need to switch over now back to, I want you to see the code. We have an Asterisk server, and the path goes like this. These wires go to my ATA, the ATA goes to a switch down beneath me, that switch hopefully goes to the internet. It didn't seem to go a minute ago when I tried, and of course if it doesn't, then the show is over. But this is the dial plan logic that basically, I'll keep talking, don't worry. You just won't get to see the thing happen. But anyway, and this is available for you in the notes, but basically here's the key. I got some prompts, thanks to Ellison Smith, all right? And so classically, when I make the call, you're going to hear number, please. And at that point, I pass the call off to a speech recognition AGI. That then is hooked up to Google's speech recognition technology. That is, I signed up for a Google Cloud account. I have chosen their speech recognition API. I wound up with a special developer ability. It's a private API you can't normally get at, but I send it off to Google, come back then, and there is a routine in here that verifies the number, because from time to time when you're talking in a 200-year-old, actually be a 107-year-old phone, it doesn't catch the number just right. But I'm going to try to demo this for you, and as I do that, now this is where we have more technology in the room to do this than you could ever imagine. We have reverse engineered a set of headphones. You know that your headphones are also microphones if you reverse them. Because the amount of energy coming out of this poor little receiver is so small, we took a headphone and hooked it up to this thing, wrapped it in duct tape and cardboard. They have it back there on like super high, ultra gain. And so you're all, not that anybody's talking now, going to have to be really, really, really quiet. And you can watch the call proceed on the CLI here. Now those things are worrisome. All those errors mean that maybe my cloud server lost connection for a while or something. But you should see this call go down now. As I turn this on, you should see it automatically connects. It connects me up there, connects me to the speech engine. And so this is where all these pieces have to work together, but there's at least 10 people in the room who've seen it happen 4 or 5 times this morning already. So if it doesn't happen now, it's your guys' fault, okay? So here we go.
The number you entered was 2 1 2 2 6 5 5 3 8 4. If this is the number you wish to call, please say yes. Say no to try again. I'll connect you now.
So, we are making a call to someone.
Well, hi, Mark. How are you doing back
There. Okay, so I have just made a call through a 107-year-old telephone, through Asterisk, through a super ATA, and I'm talking to Mark on his cell phone. And with that, I will end my presentation and open the room to questions. Thank you all very much. And it shows 14 seconds left on the timer. I made it. Okay. Thank you very much.